What if robots could understand what you want without you saying a word? Welcome back to Summarize Science. Today, we're looking at a paper that's teaching robots to be better teammates by understanding our body language. Traditionally, getting a robot to collaborate with you is clunky and slow. You might have to use specific voice commands or even type instructions. These researchers wanted to create a more natural interaction, where a robot could infer your intent just by watching your movements, something they call tacit understanding. To do this, they used a sophisticated robot arm with a dexterous hand and multiple cameras to see the world. They collected training data by having one person, the teleoperator, control the robot using motion capture gloves, while another person, the collaborator, interacted with it. They designed two simple tasks: pick up cube, where the collaborator points to a specific cube, and pass cube, where the robot hands the cube over. The brain of this operation is a powerful AI called a Vision Language Action Model, or VLA, which is designed to connect seeing, understanding language, and taking action. But they didn't just use it off the shelf. They made several key modifications to adapt it for collaboration. One of the cleverest changes was adding an auxiliary goal during training. They basically gave the AI a side task to predict where the human's hand was pointing in the camera footage. This forced the AI to learn to pay close attention to the human's gestures, even though that prediction wasn't directly used to control the robot's final movements. They also simplified how the robot thinks about moving. Instead of predicting the absolute final position, it predicts the change in position, which is a much smoother and easier problem for the AI to learn. Similarly, they found that the 16 different joints of the robot hand could be effectively represented by just 4 main patterns of movement, which drastically simplified the learning process. But when they tested it in the real world with a new person, they discovered something fascinating. The robot had developed trainer overfitting. This means it got so good at reading the body language of the original collaborator from the training data that it failed to generalize to a new person. The researchers compared this to how a dog might only obey its specific owner and ignore strangers. In their tests, the robot only successfully completed the full pick-then-pass task 1 out of 10 times with a new person, mainly because it couldn't figure out which cube was being pointed at. So, let's recap the key points. The researchers adapted a powerful AI model to allow a robot to understand human intent from gestures without needing verbal commands. They did this by cleverly forcing the AI to pay attention to human hand poses and by simplifying the way the robot plans its movements. However, they uncovered a significant challenge called trainer overfitting, where the robot becomes too specialized to one person. This work is a big step towards robots that can be truly intuitive partners in our homes and workplaces. In the future, solving this overfitting problem, likely with much more diverse training data, will be crucial. Imagine assembly line workers or surgeons having a robotic assistant that anticipates their next move, seamlessly handing them the right tool at the right time. That's the future this research is building.